Hi everybody, welcome to Camber's tutorial. This is the third lecture on organic chemistry of our crash course GATE 2021, and this lecture is about reaction mechanism. And you know that earlier two lectures I have covered the substitution nucleophilic reactions SN1, SN2, SNI and E1, E2, E1CB. This kind of mechanisms has been already discussed so far. Now I am going to discuss in this lecture about the Sayetzeff and Hoffman product. So without a further ado, I am going to start today's lecture. Well, so this is our substrate where this bromine, this Br present, is nothing but a leaving group. And if we apply the condition of the elimination reaction, there will be two possibility. One is this two hydrogen and the other one is hydrogen from this side. Okay. Now, if base abstract proton from this side, then there will be a bond formation in this way, and that is our this product, which is basically called the Sayetzeff product. And if base abstract proton from the right side, then there will be bond in this way and bromine will be removed. So in this case, a terminal alkene will be produced. This terminal alkene over here is a Hoffman product. Clear? Now point is that when Hoffman product will form and when the Sayetzeff product will form. Generally what we see, generally under normal reaction condition, Sayetzeff product is more stable. Okay, Sayetzeff product is more stable. The reason behind the stability is the substitution. Basically, Sayetzeff product is of more substituted product. It is a more substituted product. But in some special cases, we can see that Hoffman product can be formed as a major product. We will discuss those cases one by one. So let's move on to our this question. Over here, these two are the substrates, and now when this kind of reaction you will see, that means the cyclohexane ring is present. Your first attempt or first approach towards this question is to draw that cyclohexane ring in the chair form. Okay, so what will be the chair form of this ring? So if I draw it, it will be something like this. The chair form. Over here, this carbon is nothing but this one, where the isopropyl group is attached. Adjacent to this carbon, there is one chlorine which is in the below position, and methyl in this carbon. So this one is this carbon. Clear? So this is the structure of the molecule in the chair form. Now sodium methoxide is a base, and we will consider the elimination reaction possibility. In this case, we will consider the possibility of E2 elimination. You know that for E2 elimination, what we can see that there will be anti-periplanar geometry. That means I have discussed it in my previous class that suppose over here the hydrogen which is to be abstracted by base and leaving group is there. So this hydrogen and this leaving group, this CH bond and the bond between the carbon and the leaving group will be just anti with respect to each other, and that is why base will come to abstract this hydrogen. There will be the double bond formation over here and the leaving group will be removed. So this is the common condition. Now over here our leaving group is nothing but chlorine. Okay, this is our leaving group. Now consider what will be the possible anti-periplanar bonds, CH bond. Over here you will see one axial hydrogen in this carbon and another axial hydrogen in this carbon. We will not consider this one because this is not the anti-periplanar with respect to this CCl bond. So that is why we can see that this CCl bond is anti-periplanar with either this one or this one. Clear? Okay, so we will move on to the possibilities, that what are the possible products if we abstract proton. So first we will consider this one. Okay, so if base comes here and it abstracts this one, this proton, it will produce a double bond in this position and your product will look like this. This will be your product. Okay, when the base comes to abstract this hydrogen. Another possibility is that when base comes to abstract hydrogen from this carbon atom, now there will be a double bond formation in this side and your product will be something like this, double bond in this position. Okay, now considering these two double bonds over here, if we see this double bond, it is 1, 2 and 3. With respect to this double bond, it is nothing but your tri-substituted double bond. But in this case, what you can see, that this double bond is di-substituted. Okay, there will be two hydrogen with this double bond, so it is a di-substituted one. We know that more substituted product will be your Sayetzeff product, and under normal reaction condition, Sayetzeff product is your major. So under this condition, what I can say, that this one will be the major product. This will be your major product in this reaction. Now if I draw it in this formation, so that will be something like this. So there will be this isopropyl group, double bond in this carbon, and the methyl group. Okay, so this is nothing but your product of this reaction. Well, let's discuss about this substrate, second one. So in this case, what I can see, that if I draw it in the cyclohexane structure, so that will be something like this. Chlorine in this side and methyl will be present over here. Now here if we consider this carbon chlorine bond, okay, this carbon chlorine bond is not perfectly anti-periplanar with its adjacent hydrogens. So these hydrogens are not in the suitable orientation. So what it can do, now it has one more possibility, that ring flipping can move this equatorial carbon chlorine bond into the axial carbon chlorine bond. Okay, so we will draw the structure after flipping. Over here carbon chlorine is bond is now even axial and its adjacent hydrogens are like this, and methyl will be present in this way. Now over here it is easy to be identified because this carbon chlorine bond and this CH bond are anti-periplanar with each other, and that is why when a base comes, base will abstract this hydrogen, there will be bond formation and chloride will be removed as a leaving group, so your product will look like this. Now here, since this methyl group and this isopropyl group both are in axial position, so this is not a suitable conformation, so we will flip the ring again to produce this kind of structure. Okay, although there is a double bond inside the ring, so it will not be a perfectly chair conformation, so I'm not going to draw that structure, that will be more complex. For our understanding purpose, it is okay to visualize the molecule in this way, that the product in this case will be this one, and this is the only product. Okay, this is the only product. In this case, what we can see, that over here the ring structure and the geometry of the bonds That means whether it is syn or anti, depending upon that our product can change. Now over here, in this case, what was our product? Our product was something like this, where double bond is present in this position. This was our major product, although a minor amount of this has been produced. Okay, a minor product has been produced over here, but that is a minor amount. So there will be a mixture of these two type of product can be obtained in the first case. Anyway, so from this kind of structure, what we can see that in the second case there will be a ring flipping, and due to the ring flipping, these all bulky groups, okay, bulky groups come at axial position, okay, and that is not that much stable. It is not so stable, although it is an intermediate. You can think that it is one kind of intermediate structure, but that intermediate is not that much stable. That is why if I designate the rate constant of these two reactions, suppose the rate constant of the first reaction is K1 and that of the second reaction is K2, then obviously K1 is greater than K2. So this will be a slower reaction. Clear? Okay. Now we will discuss the cases where the Hoffman product will be measured. Hoffman product signifies that the less substituted, okay, less substituted alkene is produced. So what are the possible cases? Number one, if I take a substrate like this, okay, now over here fluorine is attached with the carbon, and you know that this CF bond is to some extent strong bond, and that is why F is not a good leaving group. So our first point is that in presence of poor leaving group, Hoffman product becomes major. Okay, now over here with respect to this fluorine, in this carbon one hydrogen is present, and over here two hydrogens are present. So the double bond can form in this way, so that we can get this product, and double bond can form the other way. That means in this side it can produce. Now over here it is a disubstituted, okay, it is a disubstituted alkene, and in this case it is nothing but your trisubstituted alkene. If you consider this one, you can see that it is a trisubstituted alkene. So obviously more substitution means that will be a set J product, and lesser substituted alkene means it is nothing but your Hoffman product. Now when this leaving group is weak leaving group, so this will be your major product. That means a Hoffman product will be major in this case. Clear? Now we will discuss the second point. Suppose I am giving you a substrate like this. Okay, so with this substrate, in the first step I am treating it with methyl iodide excess in presence of Me2SO4, and in the second step I am giving Ag2O8. Okay, now the first step is a name reaction which is called the Hoffman exhaustive methylation. So in this Hoffman exhaustive methylation, what we can see that there is stepwise methylation of NH2. It is nothing but your stepwise methylation of NH2 to NR3 plus. That means a quaternary ammonium salt. Clear? So what I can see that over here, when excess methyl iodide is used, so first step is the methylation of this nitrogen, and you will see the product will be something like this. After taking one methyl group, it will be something like this. Now still it has a lone pair. Now again one methyl iodide is there, it will again attack to this one, thereby you will get this kind of product. This is nothing but a stepwise methylation what I am showing in this way, and still it has a lone pair. So now again another molecule of methyl iodide it can produce this way. This is nothing but your quaternary salt. Okay, and now this iodide will remain in proximity with this cationic species. That means quaternary salt is obtained. In this way, the Hoffman exhaustive methylation performs the formation of the quaternary ammonium salt. Now this quaternary ammonium salt, if you take a look at the structure, this one behaves as a good living group. This can behave as good living group. And now it has some possibilities. That means it can abstract proton from this carbon because it is the adjacent carbon, and it can abstract proton from this one. This side there is no proton. Now what will be the product? If we draw the two structures, suppose in the case A, suppose case number A is abstraction of this proton. So now base will abstract suppose this proton, and there will be a double bond in this way, and it will be removed. So our product will be this one. This will be our product. But when the base will approach from this side, okay, that means the base now approach from this side, it is now abstracting proton from this carbon. So now it is producing a double bond in this position. So that is why this will be our product. Okay, it is nothing but your disubstituted alkene, and this first one is your trisubstituted alkene. So from this context what I can see that over here it is your Sayetzeff product, and in this case it will be Hoffman product. But since there are three groups and over here a bulky group is present, so that is why this Sayetzeff product is less stable due to the presence of this bulky group. So what is our condition? I can see that over here the major product is this one, because this alkene is to some extent statically free, or statically to some extent less hindered. Okay, it is statically less hindered alkene. Okay, so the condition is that you can think that when substrate is bulky or it has some bulky substituent, then there is a possibility of Hoffman product as major product. Okay, so this depends upon the bulkiness of the substrate molecule. Clear? Okay, so that's all for this class. In the next class we will start our NGP, that means a neighboring group participation reaction. So stay tuned with Canvas tutorial. If you like my video, please do share and subscribe. Thank you. Happy learning.